As the number of switches increases, on a small or medium-sized business network, the overall administration required to manage VLANs and trunks in the network becomes challenging. Imagine that you are network administrator at ABC Company, and your company's network system have 50 switches, connected somehow using VLAN trunks. Let's say there are already 10 VLANs implemented, and you want to add VLAN 20 to all switches. That means, you would have to log in into all 50 switches, and enter the same config commands, to create a new VLAN, which may result in inconsistency in VLAN configuration, and time-consuming tasks. So, how do you save yourself from these problems? The best practice is to use VTP. VTP allows you to rescue yourself from these problems. VTP is a Layer 2 protocol that maintains VLAN configuration consistency by managing the additions, deletions, and name changes of VLANs across networks, which makes VLAN management or configuration and troubleshooting easier. VTP will let you create VLANs on one switch, and all other switches synchronize automatically. In other words, it would allow the network administrator to create a new VLAN, example, VLAN 50, on one switch, and then all the rest of the switches would automatically learn about a newly created VLAN information, such as VLAN ID and name, using VTP. This minimizes problems caused by incorrect configurations and VLAN configuration inconsistencies. Moreover, VTP only learns about VLANs created with normal range IDs, VLAN IDs 1 to 1005. For the purpose of dynamically announcing VLAN configuration information, VTP has three components. VTP organizes all switches under the same administrative domain, which causes all switches to have the exact same configuration of VLAN information. VTP domain consists of a set of interconnected switches with the same domain name and password. All switches in the same domain share VLAN configuration details by using VTP advertisements, while those that are in different VTP domains do not. VTP advertisements, or messages, distribute VTP domain name and VLAN configuration changes to VTP-enabled switches. Each switch in a VTP domain originates a VTP frame and advertises it over the trunk port periodically. Neighboring switches receive these advertisements and update their VTP and VLAN configurations as necessary. A switch can be configured as a VTP server, client, or transparent mode. However, switches use either VTP server or client mode when the switch wants to use VTP for its intended purpose of dynamically advertising VLAN configuration information. VTP allows a network administrator to manage VLANs on a master switch configured as a VTP server. The VTP server is where VLANs can be created, deleted, or renamed for the domain, and then it advertises and distributes VLAN information over trunk links to other VTP-enabled switches in the same VTP domain. In addition, VTP servers store the VLAN information for the entire domain environment. VTP clients function the same way as VTP servers, but you cannot create, change, or delete VLANs on a VTP client. Thus, it always listens to an advertisement from the VTP server to learn about the changes to the VLAN configuration and VTP domain. In addition, it can forward advertisements to other VTP clients. The third VTP mode, transparent mode, causes a switch to ignore VTP. Transparent switches do not participate in VTP, except to forward VTP advertisements to VTP clients and VTP servers. In addition, a VLAN that is created, renamed, or deleted on a VTP transparent switch is local to that switch only. VTP Configuration Revision, that indicates the VTP frame revision level. VTP Think VLAN Configuration, as one VLAN configuration database. The configuration database has a configuration revision number, which is incremented by 1, each time a server changes the VLAN configuration. In other words, each time a VLAN is added or removed, the configuration revision number is incremented. However, the VTP domain name changes cause the revision number to resets to 0. The VTP revision number has been reset to 0, because the VTP domain name has changed from null. Verify that the VTP domain created on the VTP server has been distributed to VTP Client 1. If not, restart the switch device. As you can see from this demo, the VTP domain has already been distributed to VTP Client 1. However, no VLANs were distributed, because the VTP domain was not password protected, and VTP operating mode was not changed. Now, check if the VLANs created on VTP server have been distributed to VTP Client 1. See, all VLANs have been distributed.